What we have here, we've got a dual output power supply set to 24 plus 24, which is giving us 48 volts end to end, and the current limit on it is 2 amps. And if the power supply, if the meter were to turn red, it would indicate that this circuit's taking too much current, and we'd see it on the ammeters anyway. But so far, when we've switched on the apparatus, I'll switch it off now, it goes down to something insignificant. There are 0 milliamps effectively. I'm turning on the Crystalite controller, and the current goes up to a standing value of just short of 60 milliamps. And I believe I've got the switch set in the Crystalite controller in the 50 volt range, so that's correct. What I would expect to happen is when I turn the throttle, I would expect at the very least that we'd get a kick out of the motor, but nothing happens. There we are, I just did it, I'll do it again. And this controller together with this throttle have been used to drive a Crystalite motor, so we know that that is sound. I've independently tested the motor. I've connected the phase outputs, which are on these wires here, to a 5 volt power supply and to the oscilloscope, and we've turned the motor by hand and recorded the waveforms, and we get classic 120 degree separated square waves with 50-50 duty cycle, and that means equal on and off time, and the only difference is they're shifted 120 degrees each time. So the signal that's coming off the motor when you turn it by hand is exactly what you'd expect it to be.
Yeah.
I've also done a very naughty test. I've taken the phase wires and I've dabbed them onto a power supply, and I've picked in pairs, and I've dabbed one pair onto the power supply, and the motor goes tick, and I dab another pair on, it goes tick, like that. So obviously it's drawing current. Needless to say, there's continuity through the motor windings. But even if one motor winding was open, or something like that, we would still get a kick when we turn on the speed controller. I believe that the logic signals coming out of the motor and going into the Crystalite are going to be the same. They're standard 0 and 5 volt levels. My next experiment, which I'm going to try, is I'm going to put an inverter package, a CMOS inverter package. I'm going to take the signals from the motor, invert them and feed them to the Crystalite. But I think that's really last gasp. I don't think that's going to be successful, because if that was the problem, the motor would buzz or just grunt at us and not turn properly. Because my experience with motors like this is if you inadvertently diss with the model aircraft motors and things, if you diss feedback, the thing grunts a bit and then maybe the power supply trips.
Yeah.
So we've tried just about everything now. We know the Crystalite controller works. It works very nicely on Andrew's semi-recumbent with a standard Crystalite 2 kilowatt motor in its 100 volt range. We've tried it in its both 100 volt range and 50 volt range. It takes, when we plug in the
Cycle analyst.
Thank you, Andrew. The cycle analyst, and we turn this control, we see the bar graph going up and down, so we know it's actually accepting this signal. And also it's been tested with this speed control. It's been tested with this throttle grip. So there we are.
All a bit of a mystery.
It is, and if it wasn't for the fact that Andrew has taken this Crystalite controller home and this throttle and put it back onto the semi-recumbent, and then it just worked.
It worked.
And so that confirms to us that the motor controller is okay.
And incidentally, we've seen 12 kilowatts go through that Crystalite motor when a rather heavier person than I used it.
Yes.
Anyway, so
that's it.
That's where we are at the moment, Mike, and this is where it is, and there's the top of it.